class 8 physics and the topic is heat transfer, and we'll be continuing with what we have been doing last time. So last time we discussed about evaporation, how evaporation is affected by different rates. So today we'll be discussing about evaporation causes cooling. Evaporation causes cooling. Now, this is one fact, that evaporation causes cooling. Okay, this is one major difference between evaporation and boiling. Evaporation causes cooling, boiling does not. Now, why does evaporation causes cooling, or how does evaporation gives us that cooling sensation? So let us discuss some examples. Okay. When you put something on your palm, say you put a spirit, or you put a spirit on your palm, and then what happens is after some time you feel that cooling sensation, isn't it? When you feel very hot and when you're sweating profusely, or when you're sweating and you sit next to a fan, what happens? You feel that cooling sensation, isn't it? You get that soothing effect, right? It is because evaporation causes cooling. Now, how does evaporation causes cooling? Now, see here, as you know that during the process of evaporation, the heat is either supplied or the heat is either absorbed from the surrounding. Okay, if the heat is not supplied, if the external heat is not supplied, then what will the object do? It will take the heat from the surrounding and then it will evaporate. Okay, for example, as we discussed about a person sweating and then sitting next to a fan, I said it gives you a cooling effect. Now, how does it give? It happens just because when you're sweating, okay, there are water droplets in your body. And then when you sit next to the fan, you know, last time we discussed that evaporation is increased by the blowing air. So when the air comes to your face, okay, the water droplets, the sweat, which is in the form of water droplets, okay, the sweat will be taking heat from your body in order to evaporate. Okay, the sweat, the water particles which are in the form of sweat, they absorb the heat from the body. Okay, there no external heat would be supplied to it, so it absorbs the heat from the body. And then when it absorbs the heat from the body, the liquid changes to vapor, which means we say the liquid has evaporated. So when the liquid absorbs the heat from the body, so the body's temperature will become less. Okay, when it absorbs the heat, loss of heat means decrease in temperature. So when the body loses heat, there is decrease in temperature. Thus you feel the cooling sensation. You might have seen those dogs also. Even the dogs feel very hot, they pan their tongue, they take out their tongues out, isn't it? You've seen them. So why do they do it? Is because the saliva which is in their mouth, okay, they evaporate. And how do they evaporate? By taking the heat from the tongue. Okay, they take the heat from the tongue. That is why evaporation is said to cause cooling, because in evaporation, during evaporation, if external heat is not supplied, then the heat is absorbed from the surrounding. Okay, so what does it do? The particles, the liquid particles, they absorb the heat from the surrounding and then they vaporize. Okay, so this is why cooling is produced during evaporation. Now, cooling produced during evaporation, reason, I am reading it from the book. So you can refer to your book, page number 107. In the process of evaporation, a liquid changes to vapor, and for this purpose, some heat is needed. If there is no external supply of heat, the liquid will draw the required heat from its surrounding. And the example over here is given for your palm. So when you keep ice on your palm, the ice melts, isn't it? You've seen that. And when you keep water in your palm, the water will vaporize, giving a cooling sensation to your hand. And where does the water get the heat from? To change the process, it absorbs the heat from the palm. Okay, so that is why evaporation causes cooling. I hope it's clear with you. The next topic that we're going to discuss today is boiling. Okay, so you know evaporation and boiling are two forms of vaporization. So vaporization, what is vaporization? Vaporization is the process in which liquid changes to gases by absorbing heat. Okay, liquid changes to gases when it absorbs heat, when heat is gained. And vaporization are categorized in two types. One is evaporation, the other one is boiling. Now, we've discussed about evaporation already, all the how does evaporation take place, what actually is evaporation, what are the factors that affect evaporation, and today we will be discussing about boiling. Now, boiling is a phenomenon in which liquid changes to gases at a particular temperature. Okay, it requires a particular temperature. It cannot just take place at any time. Okay, so boiling is a process in which liquid changes to gases at a particular temperature. That is very important. When you're defining boiling, you have to mention that boiling takes place at a particular temperature. Now, why do we mention that? Because boiling cannot take place at any time like evaporation. Okay, unlike evaporation, boiling requires a certain temperature. That means a certain amount of heat has to be absorbed before the liquid boils. And different liquid boils at different temperature. That means it requires different amounts of heat in order to boil. Okay, also depending upon the quantity, amount of liquid. Now, explanation of boiling by molecular motion. When a certain liquid is heated, there is a rapid formation of vapor from all parts of the liquid as indicated by visible bubbles. Heating of the liquid increases the average kinetic energy of the liquid molecules. When the molecules acquire sufficient kinetic energy to do work against the force of attraction of other molecules. Now, what happens during boiling is, say, you have a vessel and you need to supply heat for boiling. Okay, it doesn't absorb the heat from the surrounding. The heat has to be supplied for this. So when you say you're boiling, you've kept water here, and water which is in the form of liquid. Okay, now what are you doing over here? You're supplying heat. Now when this water particles start gaining heat, the particles which are closer to the they will get heated. The particles will get heated. They start moving faster, and then they go up. Okay, the hot particles they start rising up. Now, when the hot particle starts rising up, what happens over here? The hot particles have already gone up. What is happening over here? It's become vacant, empty. So what happens? The cold particles which are already above, they will come down. Okay, the cold particles will come down. These cold particles get heated again, they go up. and then the process continues till all the liquid starts boiling. Okay, and you might have seen the boiling. The boiling is indicated by the small bubbles that you see when the liquid gets boiled. Okay, the bubbles indicate that the liquid has started boiling. So this is how it actually happens. This is how boiling takes place. The hot particles which are closer to the heat or which absorb a lot of heat, they rise up. The hot particles rise up. The cold particles fill their space. The cold particles get heated. Then their kinetic energy increases. They move up. Another set of cold particles come down. They get heated. Again they rise up. And then the process continues till all the particles start boiling. And when the liquid starts boiling, they start changing into vapor. Okay, now there is a factor which affects the boiling point. In fact, there are some other factors also, but I am talking about the factor which is mentioned over here on the book. Okay, and that factor is pressure. Now pressure affects the boiling point. Okay. The atmospheric pressure affects the boiling point of a liquid. Now how does the pressure affect the boiling point? If the pressure increases, the boiling point also increases. If the pressure decreases, the boiling point also decreases. Okay, that's why we say boiling point is affected by the pressure, the atmospheric pressure. Okay. Now, the pressure exerted by the reason why the pressure is the boiling point is affected by the pressure is because the boiling point, the pressure of the boiling point, okay, the pressure of the vapor and the pressure of the atmospheric pressure will always be the same in a surrounding. Okay, for example, we are in a hill region, so whatever is the atmospheric pressure, the vapor pressure will be the same. That's why if the pressure is less, atmospheric pressure is less, the boiling point will also be less. That means they have to balance each other. So in order to balance each other, if the atmospheric pressure decreases, the vapor, the boiling point also decreases. If the atmospheric pressure increases, the boiling point also increases. This is because to balance with the atmospheric pressure. Now see here, the reason is that at the boiling point, the pressure exerted by the vapor of the liquid is equal to the atmospheric pressure. Thus, the boiling point of liquid depends on the surrounding atmospheric pressure. So, if you are in plains, if you are in a sea level, the atmospheric pressure would be more. If the atmospheric pressure is more, the boiling point will also be more. Here, when you just go to a higher altitude, when you climb up to a higher altitude, what happens? The atmospheric pressure also becomes less. You know, with increasing height, the atmospheric pressure decreases. So, if the atmospheric pressure decreases, the boiling point also decreases. That is why the boiling point of a liquid, the boiling point of water here on the hills and the boiling point of water on the sea level, that is on the plains, would be different. Okay. Okay, with the increase of the atmospheric pressure, boiling point of a liquid increases to increase the vapor pressure and make it equal to the atmospheric pressure. As I told you this already, that the vapor pressure and the atmospheric pressure has to be balanced. In order to balance it, when the atmospheric pressure increases, the vapor pressure also increases. And when the atmospheric pressure decreases, the boiling point also decreases. And that is why at the mountains atmospheric pressure is low, and thus water boils at a temperature below 100 degrees Celsius. Okay, so it becomes difficult to cook food over here in mountains or in as we climb up, as we go to higher altitude. What happens? It takes more time for the food to get cooked because the boiling point of water is less compared to the areas which are near the sea level. Okay, because the atmospheric pressure would be more. Atmospheric pressure will be more at sea level, and as the height increases, atmospheric pressure decreases. And when the atmospheric pressure decreases, the boiling point also decreases. So water boils at less temperature. That means lesser than 100 degrees Celsius. And thus, it becomes difficult for the food to get cooked easily. And that is why, at a higher altitude, pressure cookers are used, because it kind of balances the pressure. It creates a vapor pressure inside the cooker, and thus the food gets cooked faster and more properly, in fact. So it not only consumes time, but it also consumes energy. Okay, on the other hand, in a pressure cooker, by keeping the water vapors inside it, the surrounding pressure is increased. Then water inside it boils at a temperature nearly 125 degrees Celsius. This one we are talking about pressure cooker. So why do we use pressure cooker? So that the food gets cooked easily, because as what happens inside the pressure cooker is the vapor is not allowed to escape. So the vapor, they remain inside the cooker, and they kind of create a pressure. Okay, they want to escape out, but they cannot escape. So they kind of create a pressure, and and the atmospheric pressure also outside becomes more. Okay, and thus the food gets cooked easily in a lesser time and more properly. Thus, as I said, saving energy as well. So we've discussed about the differences between evaporation and boiling in the last class only. Anyways, let's quickly revise about the differences between evaporation and boiling. So evaporation, number one, is a slow process, whereas boiling is a fast process. Evaporation takes place at all temperature. Okay, it can take place in a cool day, it can take place in a very hot day. It can take place at any temperature. Whereas it requires a definite temperature, which is called the boiling point. Okay, boiling requires a definite temperature, a fixed temperature, which is called the boiling point. Okay, evaporation is a surface phenomenon. Surface phenomenon means it only takes place at the surface. And I explain you why does it take place only at the surface, isn't it? Because the particles, when they collide with each other, the particles which gain a lot of energy, they go up to the surface and they escape out. And the particles which have low energy, they remain inside. Okay, so evaporation is a surface phenomenon, whereas boiling takes place throughout the liquid. Boiling takes place throughout the liquid. It causes cooling. Okay, evaporation causes cooling. Boiling does not. Okay, boiling does not cause cooling. So these are the differences that we know about evaporation and boiling. Evaporation is a slow process, boiling is a fast process. Evaporation takes place at all temperature, boiling requires a definite temperature. Evaporation is a surface phenomenon, which means it takes place only at the surface. Boiling takes place throughout the liquid. Evaporation causes cooling and boiling does not. And evaporation depends upon the different 5 factors that we discussed last time, and boiling depends upon pressure, the atmospheric pressure. So these are the differences between evaporation and boiling. Okay, so we'll complete here for today, and in the next class we'll continue further with thermal expansion on the same chapter. Thank you and have a good day.